This video covers applications of the dot and cross product. The first one we'll look at is an application of the dot product, which is the formula for the calculation of work. Here we've got work equals force dot displacement. If you've taken physics, you might know it as this, but we'll try to be consistent here and we'll use S. Mathematicians like to use S for displacement. So F is the force acting on an object measured in newtons. S is the displacement of the object measured in meters. And W is the work done measured in joules. So work, I'll just rewrite this here. So we've got work equals force dot displacement. And we can write this as F, the magnitude of F times the magnitude of S cosine of the angle between them. So in the first example, a sled is pulled 25 meters. So that's our displacement along level ground by a rope inclined at an angle of pi/4 radians to the ground. The tension in the rope is 200 newtons. So first thing I like to do with vector problems is to draw a diagram. So I've got a sled. I've got it being pulled along level ground by a rope. My tension is 200 newtons. My angle is pi/4. And this down here, this really represents the direction of my displacement. So in order to find the work done, I can use force dot displacement, which is the magnitude of the force times the magnitude of the displacement times the cosine of the angle between them. So in this case, my force is my tension, so I have 200 newtons. My displacement is 25 meters, and then cosine of pi/4, which is the angle between them. So when I simplified that all out and I use my calculator, I'm going to get approximately 3,540 joules. So the work done in this case is 3,540 joules. Okay, if you wanted, now we're going to do another example. Here, we've got a box going up a ramp. So we've got a 25 kilogram box. It is located 8 meters up a ramp, inclined at an angle of 18 degrees to the horizontal. Determine the work done by the force of gravity. So you might need to know this, that the force of gravity is mass times gravitational acceleration as the box slides to the bottom of the ramp. So let's draw a picture. So we've got a ramp. We've got a box. Our angle of the ramp is 18 degrees. And the box, the distance between the bottom of the ramp and the box is 8 meters. So now I'm going to draw another diagram down below to help us figure out where all of the angles go. So we have the box sliding down the ramp. This is our displacement. We have the force of gravity is directed down. So let's call that F sub G for the force of gravity. This is where my level is. So I've got 18 degrees right here. And then this part here, let's highlight it in red. That red angle represents the angle between the force and my displacement. So let's call that theta. So now I want to find the work done. So I'm going to start off with my equation. So I've got force times displacement. And I know the angle between them. So I'm going to use the modified version with force times displacement cosine of the angle between them. So now, oh, that's not a good color. Let's use purple. So the first thing I need to do is find out the magnitude of the force. So I know that I'm looking for the magnitude of the gravitational force, which we already know is the mass of the object times the acceleration due to gravity. So we have the mass in kilograms, and we're going to multiply by 9.8. okay, which is G or AG. This is the acceleration due to gravity. This is an accepted constant. You would have seen it before if you've taken physics. If you haven't, G is 9.8. There you go. So when we multiply those two together, you get about 245 newtons. And so now we can put that into our equation. So we've got 245 newtons of force times 8 meters of displacement, cosine of, well, what is the value of that red angle? Let's take a look. We've got an 18, we've got a 90, so that means whatever's left over has to add up to 180 or 180 degrees. So our theta is 72. So now we have our force times our displacement times the cosine of the angle between those two vectors. When you multiply everything out, you should get about 606 joules. So therefore, the work done is 606 joules. Let's look at one more example. This time we're going up a ramp, and so we're going to determine the minimum force. If it's applied at an angle of 40 degrees to the horizontal, required to slide the box back up the ramp. So now we're looking at the same situation. So we've got our box, we've got 18 degrees, we've got our box here, and now we've got our force, right? So imagine you're pulling a string or something like that, and it is at an angle of 40 degrees to the horizontal. So that's measured all the way from the bottom, from level ground. So if I draw a diagram here, so this is, we're going to call F sub A, my applied force going up the ramp. So I would have my applied force here. What I really need to know to be able to use this formula, work equals force dot displacement. Sorry, that's a physics habit, using D instead of S. So my force is really going to be the magnitude of my applied force times the magnitude of my displacement times the cosine of the angle between those two vectors. So I need to know what the angle in between those two vectors is. So between the force and between my displacement. So back to my diagram here, I've got my force and I've got the horizontal. Now I know that this vector here represents my physics error again there. I know that this vector that I've just drawn here and labeled vector S, that represents the direction of my displacement. So what I need to find, the angle to use in my formula, is the angle between those two vectors. I don't directly know that. I know that the angle from the horizontal to S is 18, and I know that the angle from the horizontal to F is 40. So in order to find out my theta, I just need the difference between those two angles. So here I get that theta is 22. And now I have enough information to solve for my applied force. So I know from example 2 that my work done is 606 joules. I'm looking for the magnitude of my applied force, so I can leave that as a variable. I know that I'm going back up the ramp, so 8 meters. And then the cosine of the angle between them, which I just found, was 22 degrees. So then I can solve for that, use my algebra knowledge and my calculator, and get approximately 81.7 newtons. So in order to slide the box back up the ramp, the force must exceed 81.7 newtons. So I'm going to stop the video here. This covers the applications of the dot product. The next video that I'm going to post covers some applications of the cross product.